Let's now consider this following problem. Calculate the final pressure inside a scuba tank after it cools from 1,000 degrees Celsius to 25 degrees Celsius. The initial pressure in the tank is 130 atmospheres. Looks like we're using gay-Lussacs law. P1 over T1 equals P2 over T2. Again, remember that temperature must be in Kelvin. We need to add 273 degrees to both of these to change it to Kelvin. So, calculate the final pressure. We're looking for P2, and our final temperature is going to be 298 Kelvin. My initial pressure is 130 atmospheres over 1,273 Kelvin. Now what do? I cross multiply, and we find that P2 is equal to 30.43 atmospheres. Let's do another example. A gas has a pressure of 0.37 atmospheres at 50 degrees C. What is the pressure at standard temperature? Again, we're using gay-Lussacs law. P1 over T1 equals P2 over T2. In this problem, here's my initial pressure, here's my initial temperature. Again, I have to change my temperature to Kelvin, which is 323 Kelvin. So what is the pressure at standard temperature? So we have P1 is 0.37 atmospheres over 323 Kelvin is equal to our pressure, there's our unknown, over the standard temperature. Remember, standard temperature is 273 Kelvin, or 0 degrees Celsius. But we have to do all of our problems in Kelvin. Cross multiply, and we get that P2 is equal to 0.31 atmospheres. Problem number 7. I have 73 milliliters of nitrogen gas at STP heated to 80 degrees Celsius, and the volume increases to 4.53 liters. What's the new pressure? In this problem, we're going to use the combined law because we're changing pressure, volume, and temperature. P1 V1 over T1 is equal to P2 V2 over T2. Remember, our temperature has to be in Kelvin. Kelvin, 80 degrees Celsius plus 273 is going to give us a temperature of 353 Kelvin. Let's plug in what we know now. We have an initial volume of 73, initial pressure of, let's see, standard pressure. What's standard pressure? Well, standard pressure can be 1 atmosphere, it can be 760 millimeters of mercury, it can be 101.3 kilopascals. I'm going to pick the easiest one, 1 atmosphere. So I have 1 atmosphere times 73 milliliters over my temperature, which is also at standard conditions, standard temperature 273 is equal to my new pressure, that's what I'm looking for, times my new volume, 4.53 liters, I got to change that to milliliters. Multiply by 1,000, 4,530 milliliters over my new temperature, which we calculated to be 353 Kelvin. Now all we have to do is cross multiply. That goes there, this comes down there, and then we calculate. And we arrive at a new pressure of 0.021 atmospheres. Let's now do problem number 8. I have 20.9 grams of oxygen in a 1 liter container at 120 degrees. What is the pressure in millimeters of mercury? Well, as soon as I see mass, I know I'm going to be using the formula PV equals nRT. There's no change in conditions. I just want to find out what the pressure is given the volume, the temperature. I know R, and I guess I'm going to have to change 20.9 grams of oxygen to moles. Well, let's do that. 20.9 grams of oxygen, diatomic, 1 mole of oxygen over 32 grams of oxygen. And we get 0.65 moles. Let's now plug that in to PV equals nRT. Now, we're looking to find our pressure, so we have pressure times volume, and it's a 1 liter container, is equal to N, there's my number of moles, okay, my R is equal to 0.0821 liter atmospheres per Kelvin mole, times my temperature, which has to be in Kelvin, that's 393. So let's solve for pressure. This gives me a pressure of 20.97 atmospheres. Now this would be a great answer, except for the fact I asked, what is the pressure in millimeters of mercury? The last step of this problem now is to change 20.97 atmospheres to millimeters of mercury, and there are 760 millimeters of mercury per atmosphere. So when we calculate this, we're going to get a pressure of 15,937 millimeters of mercury. Let's now consider these problems involving Dalton's law of partial pressure. What is the total pressure of a mixture of gases made up of carbon dioxide, oxygen, and hydrogen if the partial pressures are 22.3, 44.7, and 112 kilopascals respectively? Well, remember, P total is just adding all of the individual partial pressures of a mixture of gases. So all we're going to have to do is add 22.3 plus 44.7 plus 112. This gives us a total pressure of 179 kilopascals. Remember, all you do is add up the individual partial pressures. Let's now do number 10. A balloon contains helium and oxygen. Helium, oxygen. If the partial pressure of the helium is 70 and the total pressure is 110, what's the partial pressure of oxygen? Well, what's my total pressure? My total pressure is 110. And my partial pressure of helium is 70. That means 110 minus 70, that's going to give me a partial pressure of 40 kilopascals for oxygen. So what's the partial pressure? 40 kilopascals. Now number 11 is a little bit more difficult. What is the partial pressure of each gas in a mixture which contains 40 grams of helium, 56 grams of nitrogen, and 16 grams of oxygen if the total pressure is 5 atmospheres? In this case, we're going to have to change each of these to moles and then find the total number of moles of gas in this problem. So, 40 grams of helium times 1 mole of helium over 4 grams of helium. That means we have 10 moles of helium, don't we? Now what about nitrogen? Nitrogen, 56 grams of nitrogen times 1 mole of nitrogen over 28 grams of nitrogen. Remember, nitrogen is diatomic. Helium isn't, but nitrogen is. This means we have 2 moles of nitrogen. Well, I'm going to do oxygen up here. How's that sound? So, I have 16 grams of oxygen times 1 mole of oxygen over 32 grams of oxygen. Well, this one I can do in my head too. This is half a mole. So, what is the total number of moles I have? I have 10 plus 2 plus 0.5. I have 12.5 moles of gas. So, let's review. I have 10 moles of helium, I have 2 moles of nitrogen, and I have half a mole of oxygen. Oops. When we add it up, we get 12.5. So, when we do this problem, what is the mole fraction for each of these substances? Well, for helium, it's 10 over 12.5. There's my mole fraction, chi, of helium. Well, what's my mole fraction of nitrogen? Nitrogen is 2 over 12.5. That's my mole fraction of nitrogen. And then I have 0.5 over 12.5, and that's my mole fraction of oxygen. So now, here are my mole fractions again. 10 over 12.5, 2 over 12.5, and 0.5 over 12.5. Remember, the partial pressure of a substance is equal to the mole fraction times the total pressure. That means to solve this problem, we are going to multiply each of these mole fractions, this times my 5 atmospheres, this times my 5 atmospheres, this times my 5 atmospheres. So my partial pressure of helium is equal to 10 over 12.5 times my total pressure of 5. My partial pressure of nitrogen is going to be equal to my mole fraction 2 over 12.5 times my total pressure of 5. And then my partial pressure of oxygen is going to be equal to 0.5 over 12.5, again, times 5. When I calculated, this is what I came up with. The partial pressure of helium is 4 atmospheres. The partial pressure of nitrogen, 0.8 atmospheres. And the partial pressure of oxygen is 0.2. Step 1, change grams to moles. Step 2, add the moles together. Step 3, come up with the mole fraction. And the next step and the last step, multiply the mole fraction times the total pressure to find the partial pressure of each gas.